Hello guys, welcome back to Maths on African Motives. We are still on our mathematics for grade 12, and this is a revision on our derivatives as we have done the first principles and also the basic rules of our derivatives. So we are able to answer something like this. This is question number 6 with 14 marks. So this is 14 marks that we are going to consider. Let us see the time that we have. All right, the first part of question 6, which was 6.1, given f of x, which is 2 minus 3x squared. From that f of x, you are being asked to determine the first derivative with respect to x from first principles, and that's 5 marks. So usually for first principles, yes, it's going to be 5 marks, something like that. So I'm just going to try utilize this space that I'm having here. 6.1, we do understand that from the f of x that we are given, which is 2 minus 3x squared, in order for us to use the first principles, this is the part that we explained before, the definition of the derivative, which is our first principles. And like I said, also you're given this in your formula sheet. If you are to consider this part, you are given what? That formula. So you're not supposed to worry about that. The formula is already stated or given in the formula sheet. So it is just using that from your information sheet. So that is the derivative. In this case, that's f prime x. So our f prime, the first derivative with respect to x, is going to be limit as h approaches to 0 of f of x plus h minus f of x everything over h. So that is our formula. And from the formula, we can see that f of x is already given. That is the original function, this part of our f of x. So what we need is f of x plus h. All right, so let us do that. We have this, and our f of x plus h. All right, let me just do this. Our f of x plus h, remember, it simply means in place of x on our f of x, substitute what? X plus h. So it was going to be 2 minus 3. In place of x squared, you put x plus h. So that's x plus h what? Squared. And guys, I have told you about this expansion. You can do it the way that you understand, but at the end, you are going to obtain x squared plus 2xh plus h squared. All right, remember our expansion. And 2, then here, the minus 3 has to expand this bracket. So you must multiply each term by negative 3. Negative 3 times x squared, negative 3x squared, negative 3 times 2xh. So that's negative 3 times a positive, which is negative 6 xh, and negative 3 multiplies the h squared. So that is going to give us negative 3. That was going to give us negative 3h squared. All right. We do not have like terms in our case. So we are going to take this, our f of x plus h, into the what? Into the formula. So thus, the first derivative with respect to x is going to be the limit as h approaches to 0 of our f of x plus h, which is this part here. So we're going to just take this part as it is, 2 minus 3x squared. All right, minus 6xh minus 3h squared. That's your f of x plus h minus f of x, the original function that you are given here, 2 minus what? 2 minus 3x squared. So put that in bracket so that you have to affect each and every term by the negative. So that is the whole idea, guys, as we can see. All right, so let us expand our bracket. So this is what you're going to have. All right, the limit as h approaches to 0 of expand the bracket. So meaning say this part I'm just going to rewrite as it is 2 minus 3x squared minus 6xh minus 3h squared. Then expand by negative, negative times 2, that's negative 2. Then negative times negative, here is going to be positive 3. So that's positive 3x squared everything over what? Over h. And this, we can collect our like terms where we have got what? Where we have got like terms. We are going to collect the like terms and simplify. Collect your like terms and simplify. That's 2 minus 2. That is going to cancel. That's a 0, right? Minus 3x squared here plus 3x squared, those are like terms, gonna cancel again. Minus 3 plus 3, that's a 0. So you are left with these two terms, minus 6xh minus 3h squared, everything over h. All right, so this is what you have. And you must get rid of h in the denominator by separating the terms or by factorizing. All right, we can separate the terms. Remember, each part here in the numerator over what? Over h. And that was going to give us negative 6x, negative 3h. All right, which is the same thing as factoring out the h, then divide by the h in the denominator. So this is going to give us negative 6x, negative 3h squared divided by h is going to be negative 3h. Everything over h. Remember your factorization. These two can cancel since we've got a product. Remember, guys, I explained this. And thus, you are going to have what? The limit as h approaches to 0 of this bracket minus 6x minus 3h. Then let us apply our limit. Where we have got h, we are going to put what? A 0 in place of what? In place of h, because we're saying h is approximating to 0. So that was going to be negative 6x, all right? Negative 6x, negative 3 times h, which is 0. And this was going to give us a 0. So therefore, we are going to remain with minus 6x. So this is our first derivative with respect to x. That is what you're going to have. So as you can see, guys, the simple part, just following the formula. This is what you were going to have at the end. And I want us to refer this back from our general rule. All right, we obtained that our answer is what? Our answer is negative 6x. From the general rule, is it the answer that we are supposed to obtain? All right, let us prove with our general rule. The general rule, remember from our previous class, all right, there was this one where we applied f of x is equal to ax to the exponent of n. We can drop the power, then subtract 1 from there. So let us consider what we have. The first part here is what? A constant, which is 2 is a constant, and the derivative of a constant is going to give us what? A 0 from our explanation. So that's a 0, all right? Then here we are going to drop the power, subtract 1. So that's 2 times what? Negative 3, which is going to give us negative 6x. You subtract 1 on your power. So 2 minus 1 is 1. So that's 0 minus 6x, which is simply minus what? Minus 6x. Exactly the answer that we obtained. So you see, guys, it is easier to use the general rule, but we cannot use it because you are told that you must use what? First principles, and they even wrote this one in upper caps so that you can see. All right, so use what you're given. That is for 5 marks, but you can prove with what? The general rule to see if your answer is correct. So the general rule is the one that you're going to use from 6.2, where you are being asked to determine these derivatives. You are not told from first principles. So when you are not told that it is from first principles. Therefore, use your what? Your rules of differentiation, where I said you're going to expect these conditions, brackets, fractions, exponents, and those roots which are part of your sets, where you must rewrite in the form of what? Ax to the exponent of n and differentiate. All right, so the first part, they wanted us to determine the first derivative with respect to x, but this is wrongly written. It was supposed to be f of x is equal to, but this is what you're supposed to determine. All right, so 6.21, our f of x is equal to x to the exponent of 4 over 2, x to the exponent of 4 over 2, plus x to the exponent of 0 minus pi t squared. And you're being asked to find the first derivative with respect to what? To x. So remember the condition, drop the power, subtract 1 from our laws. Everything is in the standard form, so we can just apply the concept dropping the power, then subtracting 1 from the exponent. That is the idea there. So here we're going to drop the power. So it was going to be 4x to the exponent. We subtract 1. So that's to the exponent of 3 over what? This 2 that you're given. So that was going to cancel. 4 divided by 2 is what? 2. So it was going to give us 2x cubed. So the first part was going to give us 2x cubed. All right. X to the exponent of 1, x to the exponent of 0 is equal to 1. That's a constant. And the derivative of a constant is equal to what? To 0. Whenever we've got a constant, it gives us what? It gives us a 0. All right, minus pi t squared. We do not have x here. So it means also this is what? A constant. And the derivative of a constant gives us what? A 0. So therefore, the first derivative with respect to x is going to give us what? 2x cubed from what we are given, as these ones gives us a 0. So that was the whole idea. All right, let us move on to another part, 6.2. 2, the derivative with respect to x of this. All right, that's a fraction with a single term in the denominator. So thus we are going to apply what? Separation. Remember, a plus b over c. By separation, we can separate those terms. So thus on 6.22, our dx minus 3x cubed plus the fifth root, all right, the fifth root of what? Of x squared over x squared, like this. It was going to give us, if we separate the terms, so it's going to be separated to x squared, each term over x squared. So that's the first term, minus 3x cubed over x squared, minus 3x cubed over what? X squared. The second term over x squared, but take note, it's what? Addition. So that's plus the fifth root, all right, the fifth root of x squared over the denominator x squared. Thus, you are supposed to separate the terms by separation. A over c plus b over c. But as you have separated, are you having the basic form? Are you having the standard form or not? If not, you're supposed to have this application, rewriting so that you can have the form of what? Ax to the exponent of what? Of n. This is the basic format that you must have. So the first part, we do not have that. What are we going to do? Guys, we are still on the simplification. We are not yet differentiating. We are on the simplification. We are to simplify first. So here, using your laws of exponents, same base on a division, subtract your exponents like that, x to the exponent of m minus n. So this, you're going to subtract. So it was going to be minus 3x to the exponent of what? Of 3 minus what? Minus 2. So that is going to give us negative 3 x. 3 minus 2 is 1. So that's negative what? Negative 3x. So this was going to be negative 3x. Okay. Then this also is supposed to be the same concept, subtracting. So let us rewrite the fifth root of what? X squared. Remember from our laws of exponents here, we can rewrite that fifth root from our laws of exponents. All right, sorry for that. From our laws of exponents here. So there we had the fifth root of x squared. The 2 is our power. It is your numerator. So that's x to the exponent of 2 over the number in the root is our denominator. So that's 2 over what? 2 over 5 that you are going to have. So this was going to give us x to the exponent of 2 over what? 2 over 5. But everything is over what? X squared. So it's over x squared. Now, at this stage, you are going to subtract your exponents, m minus n, x to the exponent of the power on the numerator minus this one. So that's 2 over 5 minus 2. 2 over 5 minus 2. And that's going to give us what? Let us even just use our calculator here. 2 over 5 minus what? Minus 2 is going to give us negative 8 over 5. So that's x to the exponent of negative 8 over what? Over 5. So that's what you're going to have on this part simplified. So that's plus x to the exponent of negative 8 over what? Over 5 like this. Then we can differentiate as we have got what exactly we need in terms of our derivatives. Now, as we are differentiating, do not write dx. All right. Now you're supposed to what? Differentiate. So that's the derivative of minus 3x. The derivative of minus 3x is the same as the derivative of what? Ax, a linear term. It gives us the coefficient of x, remember. So meaning to say here, the coefficient of x is what? Negative 3. So that was going to give us negative 3 if we differentiate. All right, where we have got x raised to a certain power, we are going to what? Drop the power, subtract 1 from this condition. Drop the power, then we subtract 1 from that power. So thus, we're going to drop the power, then subtract 1. So if we drop the power, it's negative to positive, which is negative 8 over what? 8 over 5. X to the exponent, we subtract 1 from our power. Minus 8 over 5, we subtract 1 is going to give us negative 13 over 5. So that's to the exponent of negative 13 over what? Over 5. So this is the idea. You're done. You have differentiated. You do not write that dx there. You're done. This is the idea. Yes, we can get rid of the negative exponent. It is up to you, but guys, for these marks, you are going to obtain full marks for doing this. All right, so that was it, separating your fractions. It is sometimes something that you must apply. We talked about that from our previous class. And also a condition like this, where you cannot separate the fraction because it is now an expression. It is different from this idea where we've got a single term. So in this case, you must consider factorizing what? The numerator. So remember, we talked about that from our previous case. Y is equal to 8x cubed minus 125 over what? 2x minus 5. It's a fraction that you have. So the only way here is to consider the what? The numerator, then factorize. We cannot separate with it's not a single term like before. So we're asked to find what? Dy dx from there. So how can we factorize this? If we take this properly, if we check it properly, we're going to see this is a difference of two cubes. A difference of what? Two cubes. 8 is a perfect cube. X cubed, 125. It's also perfect cube. If you check the cube root, you can also verify from your calculator. The cube root of 8 is what? Is 2. So it means 8 is a perfect cube. And the cube root of 125 is what? Is 5. So meaning to say, from our difference of two cubes, where we do understand that if we are given a cubed minus b cubed, it can be factorized, written as a minus b into a squared plus ab plus what? B squared. Remember your grade 10 mathematics. This is where we are taking it from. We can factorize that. So 8x cubed, 8, we saw that its cube root is what? Is 2. So it is the same as 2x, like this, everything raised to the exponent of 3. 2 to the exponent of 3 gives us what? 8. So we haven't changed anything. Minus 125, we saw that the cube root of 125 is what? Is 5. So it is the same as 5 to the exponent of 3. So we have A and B. We have that, A and B. This is your A, and this is your B. So if this part here represents A and this represents B, it follows that our factorization is going to be A minus B. First term minus that last term that you're given. That's A minus B. What is we're given here and there? So that's our A minus B. So A is what? 2x. Minus B. Our B is what? Is 5. Into what? A squared, this part, this bracket. So you're going to have a bracket, A squared. Our A is what? 2x. But it's A squared, 2x squared. That's A squared. So you must square that. 2 to the exponent of 2, that is 4. X to the exponent of 2, x squared. So it was going to give us 4x squared. Plus AB. Plus AB. A times B. What is your A here? It is 2x. What is your B? 5. So 2x times 5 is going to give us what? 10x. So that's plus 10x. Plus B squared. What is your B? Your B is 5, but it's what? Squared. B squared. 5 squared is what? 25. So that's plus 25. You have factorized that. This is your factorization. Everything over what? 2x minus 5. So guys, we can see that the denominator, 2x minus 5, is the same as the first bracket, 2x minus 5. So these two can cancel since there's a product. So you will be left with this bracket. We haven't started factorization. We are still simplifying. Now that we have got a basic part of our derivative that we are used to, we can differentiate. There's nothing that we can simplify from this. So therefore, we can find our dy dx, the derivative of y with respect to x. We have exactly what we need. So from this part, drop the power, subtract 1. So we're going to drop the power here, subtract 1. So 2 times 4, that's 8. X to the exponent of what? 2 minus 1, that's 1. So it's just x, right? 10x, the derivative there is going to give us what? 10. This is a linear. We are dealing with what? A linear. So we're just going to take the coefficient of x, which is what? Which is 10. The derivative of what? Ax, a linear, is going to give us the coefficient of x. Then 25 is a constant. The derivative of a constant is going to give us what? A 0 with respect to x. So meaning to say our answer was going to be simply 8x plus 10. The derivative of a constant, remember, is what? Is a zero. So that's it. This is how you play with these questions. As we can see, we have managed to obtain all the 14 marks. So under derivatives, guys, you're supposed to totalize. It's something that you follow. You just follow the concept, all right? So this type of questions, you must totalize. So that is it till we meet again.